Hi guys, welcome back to the YouTube channel Vivek Sani Codes. Today we are going to discuss about opposite direction pointers template. In previous video, we have already discussed regarding two pointers pattern. In this playlist actually, we are going to focus on and we are going to solve a problem related to two pointers pattern only. So to solve a problem related to two pointers pattern, first we need to understand pattern, then we need to understand template. So there are two types of template related to two pointers. First one is opposite direction pointers template, which we are going to discuss in this particular video, and another one is same direction pointers template, which we will discuss in next video. So once we will discuss these templates, basically what is template? Template is kind of structure. It is a structure of code. So by using that, we can achieve our target. If we have a structure, ready-made structure, what we can do, we can use that particular structure to solve our problem, and with due few after doing few modifications in our structure, in our existing structure template one, we can achieve our target easily. But in that case, we need to have proper understanding of that particular template, because template uh, combined with multiple scenarios. So we need to have proper understanding of those scenarios as well. So what we will do here today, we will understand all the scenarios related to a template based on few use cases. I will provide you few use cases. By using that, you will be able to understand like how we can have scenarios in our problem, how we can cross check our scenarios, and then what we will do, we will combine all these scenarios. Let's say we have these three scenarios and one we have basic structure. So we will combine all the scenarios into a single structure. And if we don't have any dynamic parameter there, let's say we have hard coded parameter, so we will remove those parameter and we will use generic or dynamic parameter there. And that final structure, final template will help us to solve our two pointers related problem. So once I will discuss two sum, three sum, four sum like this in upcoming videos related to two pointer. So there I will use directly this template based on our scenarios. We will just think about the scenarios and then directly I will use this template. And after doing few modifications, we will be able to achieve our target. So this will be our target to do it. So let's get started related to opposite direction pointer template. So here we have a few points. I will explain you everything in detail. Let's start with description. So in this template actually, pointer start from opposite end of the array. What will happen? First one pointer, left one will start from 0th index and right one will start from last index of the array. The pointer move towards each other based on certain condition until they meet. This is our second point. This is saying, so what is happening here? If we have any target, so target specific, we have three scenario. We will discuss this scenario in detail. So what he is saying here, this particular point is saying, let say we have any condition, we have any criteria, and we need to meet that. So in that case, our pointer will move towards each other. But which pointer will move and which pointer will freeze, we will understand in detail whenever we will discuss regarding this. Common use cases of this particular template: checking for palindrome, two-sum, sorted two-sum in sorted array, and merging interval. Okay, so if we have a problem like this, so we can easily use this particular template easily. So now basic structure. So this is our basic structure. Before discussing this code, and here I'm using Java. So but I'm using very straightforward Java, like syntactically it is not a difficulty to understand with C++ background people, even with Python people. So everyone can understand. Syntactically, it will be very easy. Okay, so before jumping to the code, we are going to understand this slide. So what is happening here actually? This is our first slide, and as you can see here, we have two pointers. So if let me draw it, I will explain you in detail. So these are my indexes. So this is my 0th index, this is my first index, this is my second index, this is my third index, and this is my fourth index. And this is my I can say, whether I can say I or whether I can say left. This is my left pointer and this is my right pointer. Okay. So what will happen? They will move towards each other. It will go in forward direction and it will come in backward direction. So when it will come in backward direction, what will happen? It will move from 3 to 4. Okay. So what will happen? It will happen j minus minus or right minus minus. Right minus minus. Okay. And if this pointer will move in forward direction, what will happen? It will move from 0 to 1. So what will happen here? Left plus plus. Left plus plus. Okay. Or I can write I plus plus. Whichever you comfortable with, you can use. So here in this particular problem, I will use left and right. Okay. So this is our draw. We will move like this. And let me go to the next slide. Okay. So first one is without any target. So this particular statement is saying if we have any particular criteria, we have any particular target, so in that case we will use this particular template. But this is not necessary actually. This template also have a basic structure, basic template structure. So let's say we don't have any target. Without any target, what will happen? I'm taking an example here. Let's say we have a use case. I need to swap numbers. I need to reverse an array element. So what will happen? I will when I will be here in left and I will be here right. So I will check left and right. I will do nothing. I will just swap these two number and I will move one step here from 0th index to 1 index. My left will move and right will move from last index to second last index like this. And then again they will swap these number and then again they will move one step forward direction left one and one step backward direction right one. So like this they will move. Okay. So I'm doing this. So swapping is just a logic. But what is our basic structure? What we are doing here? Without checking any target, without checking any condition, what we are doing here basically, we are moving left one direction ahead, means left plus plus, and we are moving right one direction in backward direction basically. So our condition will be right minus minus. So now you can understand this logic. But for this we need to have a loop, because we will implement iteration on our array. So how we will do this? We have a basic check here. Left, until my left will be less than right, I will continue this loop. And once this condition will not match, then I will discontinue my loop. So this is my condition. This is very important and this is need to be remembered whenever we will implement this two pointers related problem. So this is my loop, and what I'm doing, I have logic. So I have taken an example of swapping number. I can do any other thing there. So this will be my logic. Okay. This will depend on scenarios or problem statement. So I need not to worry about that. I can do anything. I need to think about it. What I was doing there. I was moving every time left plus plus and right minus minus. So this is basic structure I was using. Then we have target related, this statement related thing. Let's say we have a target. So I need to check it. So I'm checking equality. In that case, this will be my scenario number one. So what I will do, I need to move to the next slide. So here we have a target and target is 6. So what I'm doing here, and this is sorted array actually. I'm taking an example of sorted array here, and based on sorted array, what I'm checking here, I am summing up two element of array. Mean two indices we have. Those indices element sum I'm checking with my target. It could be anything. This is not mandatory. We need to do in this way only. In any other problem, let's say we need to check multiplication of two indices number. So in that case, we will check in that way. But here I'm just taking one use case, that is two sum basically. I'm taking that. So with that, I'm correlating it and I'm explaining this particular template, and this template will work in most of the problems. No need to worry about it. Will work only with two sum or some related problem. If you have multiplication related thing or any other thing, you can implement it there. That is, you need not to worry about. Okay, so what we are doing here, we have a sorted array. We are summing up two indices number, and then we are checking whether it is equal to our target or not. So we are summing up 1 and 5. So this is our current sum. 1 plus 5 is equal to sum. So this is equal to 6. That means it's matching our target. So what will happen? In that case, if we will go to the next slide, we need to move left one step ahead, and we need to move right one step in backward direction. Okay, so both move towards each other one step. So it is happening here. So means no pointer is going to freeze at that time. We are moving both the pointer because our condition is matching. Again I'm checking, it's matching. 2 plus 4 is equal to 6. Again it's matching. Then again I will do this. We don't have element here, we have only one element. So it will not meet our criteria, left less than, right, something like that, if I will move both the pointers. So if we could have multiple element here, then we do this exercise continuously. If my target is matching, in that case I will do this. So this need to be remember. So what I can do here, what was the scenario? So let's say we have one if condition, and what I was doing, I was moving this right and left. Okay, and let's say we need to implement some logic here. So code I will write here, and what condition I have, current sum if it is equal to target. Then every time what I was doing left plus plus, right minus minus. If we need to do some logic, we need to do something here, I can do. But basic structure is, if it is matching with my target, I will move both the pointers. And until unless I will be able to iterate over that particular array, I will do this particular thing, I will do this particular exercise. So this was my first scenario. Now let's jump to the second scenario, less than check. Okay, so this is scenario 2. So now jump to this slide. So what is happening here? If we have target 7, okay, and I am here at 0th index and here at last index. Okay, I'm summing up these two number. 1 plus 5 is equal to 6, which is less than my target. So my current sum here is less than my target. So now think about it. We have sorted array. This is sorted one. So which pointer I need to move? Do I need to move both the pointer? Or because there my criteria was meeting. That's why I was doing this exercise. I was moving both the pointer. But here uh, my criteria is not matching. My current sum is less than target. So that is why in that case, which pointer should I move and which pointer I should not move. So this I need to understand. So let's go to the next slide. So I have moved this. Why? Because this is in ascending order. If I will move this particular pointer, it will move. It will sum up. After summing up these two number, definitely it can provide me a better result. Okay, if I will move this pointer because this is already at its max number, so there is no need to move this number backward side. So that is why I have moved only my left hand pointer, not right hand. So I am not doing anything with right pointer. I am just dealing here with left pointer. So here I am doing left plus plus. Okay. So if I will go here and write logic for this. So what I was doing. So my condition was this. So you have noticed I haven't touched right pointer here. Okay, so this is my logic now. So if my current sum is less than target, then I will move left plus plus. I will move only left pointer. I won't touch right pointer in that case. Now scenario number 3, greater than check. So let's jump to the slide. We have these pointers. We have target 5, which is my target is less than current sum. My current sum is greater than target here. So which pointer I need to move now? Because my target is lesser. So in that case, I should not move my left pointer basically. I need to move my right pointer. So let's go to the next slide. I am moving this and again I'm checking 1 plus 4 is equal to 5, which is meeting my target. So that means I am not moving my left pointer here. If my current sum is greater than target, I am moving right pointer. So it will be right minus minus. Now jump to the scenario and write code. Okay, so here what we are doing. Right minus minus we are doing and we are doing some logic here. Okay, so no, sorry. So here we need to do it and our condition is our current sum is greater than target. So we are doing like this. So we have done with all our scenarios. Now what we need to do? Final template. We need to convert these scenarios into a final template. And with dynamic parameter. Here we are using hard-coded parameter. So target could be anything. So let's combine first these 3 scenarios into a single unit. Let's copy this from here. So this is first thing. Second scenario is this condition. So loop we have already implemented here. I need not to worry about. else if I can do, now I can implement my third condition, else if I can do. Okay, now this is looking like this. So yeah, so as you can see here, we have three conditions. If this is matching, else if it is less than this, else if, I think we need note of this. If we will refactor this code, we can remove it from here. It will definitely work like that only. Okay, so we can use here else without else if. Okay, this is refactored. Now what we need to do, we need to make parameter generic or dynamic, we can say. So let's say this param is 1 and this is 2. We don't have any other parameter here. Other parameter will be fixed. So this is our final structure of template. Now think about this basic structure. So basic structure will work when we don't have any target, but this template will work if we have any target. So let's say we have any target, then we are doing these three conditions. We are dealing with these three conditions. So we are checking like this. If we don't have any target, then there is no need of any target. We will remove all these conditions and we will just use left plus plus, right minus minus, which is our basic template. So that is why this will be our final template, which we are going to use in our upcoming problems, which we will solve by using this template. And we will just copy this structure from here and directly put in our problem solving editor, and then we will modify it according to the requirement of our problem solving, and in that case we will be able to achieve our target. So in this way we will do this. So here we understood like how this opposite direction pointer template will work, how many scenarios we have. Once we will approach any problem, in that case we need to understand how many scenarios we have in that particular problem related to this particular template, and according to those scenarios we are going to implement this template, or we need to modify this template. So you will understand once we will jump to the problem, and I will explain there how we can implement these templates in real world coding and then achieve our goals easily there. Okay, and you need not to worry about this document, because here if you will go here in two pointer, there are two templates. If you will open this, here I have already published a page, so you can go through this and you can check out this link. So this link, this website page link, I will provide in description of my video. You can check it out from there. So thank you so much guys. I will see you in next video, which will be related to same direction pointers template. Yeah, thank you. Bye bye.